So hello, I'm Ryoto Sawada from Preferred ChattyKids, and I want to express my sincere appreciation to all of you for this competition, providing a platform to share our solutions. We are from Preferred Networks Company and maybe sent to the Preferred Scantron team. So today I'll be talking about the solution titled 17 billion large language model and multi-stage. So I want to start with the resulting statement. Riemann 70 billion is truly extraordinary. This purpose can tackle over 75% of questions in trained CSV without need for training or retrieval augment generation. In essence, it possesses deep insight in the wide range of scientific fields. The bottom left figure illustrates an example of prompt to solve questions using LLM, where LLM solves the questions by estimating the probability of the word following the question. The size of the LLM model is also crucial. The bottom right table highlights the score comparison. That showcases Riemann 70 billion superiority over Mistral 7 billion by 1%. That elevates us from silver medal to gold medal. Yet, you will have a question arise. Is Riemann 7 lead too time-consuming? The answer is unfortunately yes, but don't worry, as I present the solution. So the question is how to accelerate the inference using Riemann 70 billion. Our first point of discussion is fast test time augmentation that rotates the order of the alternatives. The bottom left figure is an example of the rotation. Considering the problem as a multi-class classification, prediction results vary based on the alternative order. The impact of the augmentation is evident, shown in the bottom right figure. That display map3 score for trained CSV without RAG. Untrained Riemann 70 billion, that blue line, and trained Riemann 70 billion, orange line, both benefit from augmentation. However, naive implementation of RAG multiples the computation time for the prediction. And to counteract this, we expedite augmentation by calculating the common question part only once, thanks to Riemann 70B's casual architecture. Our second point is multi-stage implementation. As mentioned earlier, LLM provides prediction as a percentage of each alternative. We hypothesize that the maximum percentage value among alternatives reflects the confidence of the prediction. The bottom figure displays the confidence distribution for questions answered correctly and incorrectly by large language model. Clearly, confidence is low for incorrect predictions. Hence, we can skip Riemann 7 billion's prediction for questions with high confidence by Mistral 7 billion. That can reduce computational cost. The third point is fast retrieval. Many of winning solutions use dense retrieval for all wiki articles. However, we cannot use it because of computational time. We needed rapid retrieval with the computational cost of dense retrieval. Our solution involves an ensemble of space retrieval using BM25, quantized instruct Excel for all Wikipedia articles, and BGE for the STEM articles on open datasets. The bottom right table is a comparison of the computational times for the retrieval. That demonstrates our retrievals are fast enough to maintain computational time for Riemann 70 billion. So this is the summary of our solution. We trained all large language models using content-roller and employ the three-step prediction processes. Mistral 7 billion is used in the first stage to handle easy questions. And after that, we use Riemann 7 billion for more challenging questions. Right bottom table is a comparison of the solution. While the score improvement from multi-staging and ensemble retrieval might be not so big, but it is critical for drivers from price positions. And that's all from my presentation. And thank you for your time. Finally, I have to confess that I relied on large language model for proofreading to create this presentation. I asked LLM to make it similar to Steve Jobs' speech. What do you think? Thank you for your time.